Now we have a question that is based on center of mass of a system of particles. And usually the flow chart of these kind of questions becomes visualizing like this, assigning the origin, calculating the distance x1, y1 and x2, y2, and then finding the coordinates of x bar, y bar. By the formula, we know m1 x1 plus m2 x2 by m1 plus m2. Now I have a question for you here, which is based on the selection of origin. So with reference to the questions based on center of mass, calculating the center of mass of a system of particles, origin selection is really important. In this question, there are two masses, and therefore there can be many origin to be selected. But with the most logical ones would be choosing M1, M2, and COM as three different cases of origin. So the question is, which one will you choose? Will you choose M1 to be the origin, or M2 to be the origin, or COM? And if you choose these three separately, what would be the difference? How will that influence the final answer? Okay. Now the question here says that we have two masses, M1 3 kg, M2 2 kg, are placed at a certain distance. M1 is moved, so this M1 is moved towards the center of mass with a distance of 2 centimeter. The center of mass remains the same. And in which case, how much should the M2 move towards the center of mass so that the center of mass remains the same is the question. To solve this, what we need to understand first is, what is center of mass? See, center of mass in its most simplest terms is the balance point of the system. Okay. Now, when the system is said to be in a balanced condition, we know that there are two masses and this whole mass is said to be concentrated in the center of mass. But when one mass moves towards the center of mass, the system will now become unbalanced unless the other mass moves too. Okay. To restore this balance, the second mass must move in a way that keeps the center of mass in the same position. And what way is that? The center of mass remains unchanged if the weighted displacement of one mass, look at that phrase, weighted displacement of one mass is balanced by the weighted displacement of the other mass. What is weighted displacement? It basically means m1 delta x1. m1 weight representing mass, delta x1 displacement. Okay. And this leads to the equation minus m1 delta x1 plus m2 delta x2 is equal to 0, where delta x1 represents displacement of the mass m1, which is given to us as 2 centimeter, and we have delta x2, which is equal to displacement of the mass m2, which now has to be found out. Now, yes, I do understand some of you might be surprised with this equation. We'll come back to that point later. Now let us try to visualize the given scenario. So we have, this is before this diagram here represents, let me just write it down. So this diagram represents before displacing the masses, okay, and this represents after displacing the masses. And this mass here is m1, this is m2, previously m1 and m2, okay. So this was the previous position. Now for the ease of a calculation, I will choose this yellow dot to be m1, okay, and blue dot here to be m2. So what has happened? M1 has been displaced by a distance delta x1 towards the center of mass. M2 therefore has to be shifted towards the center of mass as well by a distance of delta x2. Now if you observe here, I would take M1 to be 3 kilogram, okay, and M2 to be 2 kilogram. And if you see the length delta x1 and delta x2, how would you compare them? Is delta x1 greater than delta x2 or the other way around? Okay, think of it and try to find a logical solution for that. Now we have the equation minus m1 delta x1 plus m2 delta x2 is equal to 0. And therefore minus m1 is 3 kilograms, so this becomes minus 3 in delta x1 is given as 2 centimeters plus 2 in delta x2 is equal to 0. So for delta x2 is equal to minus 3 into 2 is minus 6, transposing is plus 6 by 2 is plus 3. And therefore, in a system of particles mass m1, even the distance moved should be 3 centimeter. Okay. Now the question here comes is, how did we arrive at this equation? What is the logic behind that? Well, that is where the significance of choosing the reference point comes into picture. How? Let's see that next.